Hi, my name is Nevina, and today I'm going to be showing you how to prove trigonometric identities. So I know proving trigonometric identities can be a little scary at first, just because it's new and you don't know how to apply, but really all it is becoming familiar with the formulas and a lot of practice. So the first thing that you want to do when you do trigonometric identities is have your formula sheet right in front of you. This formula sheet shows you reciprocal identities, Pythagorean identities, the quotient identities, reflection identities, double angle formula for sine, double angle formula for cosine, double angle formula for tangent, the cofunction identities, and the addition and subtraction formulas, which we don't see as often in proving trigonometric identities, but we still use them. So the question that I chose to do is section 7.4 in the textbook. It's question 11I. This was actually part of our submitted homework, but I chose it because I thought that it provided a really good example and used a lot of the, elements that you need in solving trigonometric functions. So the question, I'm writing it down right now, goes as follows. So sine on the left side, sine 2x over 1 minus cos 2x is equal to cotangent x. It's a little backwards. It's backwards in the camera, but you can approximately see what I'm writing. So the first thing that you want to do when solving, the first thing besides, obviously having your formula sheet, the first thing you want to do is make everything the same ratios. So what this means is that you want to put any of the ratios you have, could be tangent, cotangent, secant, put everything in terms of sine and cosine. This is very important because it's the easiest way to make the two sides equal to each other. Also, once you put everything in the same, in terms of cosine and sine, you can use the other formulas to see, what equals what can you cancel out on the numerator and the denominator, etc. It's hard to explain it when you're talking. Once you see what I'm writing, it will make much more sense. So, the first thing that I'm going to do is put cotangent x in terms of cosine and sine. So we all know that cotangent is the inverse of tangent, which means that it is equal to cos x over sine x. There I have sine 2x over 1 minus cos 2x is equal to cos x over sine x. The next thing I'm going to do is I'm going to expand sine 2x and put it in terms of both sine and cosine. Here's the formula here. And it is sine 2x equals 2 sine x cos x. I'm doing the steps one at a time. So then I have this. 2 sine x cos x over 1 minus cos 2x is equal to cos x over sine x. So on my denominator, I have the double angle for cos 2x. So when it comes to cos 2x, there are really three different options to choose from when incorporating it into the solving of your trigonometric identity. So you have cos 2x equals to cos squared x minus sine squared x. Cos 2x is equal to cos 2 cos squared x minus 1, and cos 2x is equal to 1 minus 2 sine squared x. In my question, in the denominator, I have 1 minus cos 2x. So for the angle, for the formula that I'm choosing to replace cos 2x, I'm going to choose 2 cos squared x minus 1, because I know that the ones will equal to 0 once I put them in the denominator together. So it goes like this. So you can see here, I put brackets around my value. You should always put brackets. Now I'm going to expand. And this is what I have. Once I expand, I have 2 sine x cos x over 1 minus 1 minus 2 sine squared x. My 1's will be gone because they'll equal to 0 because 1 minus 1 is 0. And I get 2 sine x cos x over 2 sine squared x equals cos x over sine x. Next thing I'm going to do is cancel out the like terms on the numerator and the denominator of the left side. So crossing out the 2's, crossing out the sine squared, and crossing out sine, which leaves me with this. So once I canceled out the 2's on the denominator and the numerator, and I canceled out the sine x on the numerator as well as 1 sine x on the bottom because we have sine squared x, I was left with cos x over sine x equals cos x over sine x. And we have left side equals right side. So there we go. We solved it. Yay! So that is how you prove a trigonometric identity. What I recommend is a lot of practice and going through the process many times, as well as becoming familiar with the formulas. Becoming familiar with the formulas will make everything go a lot faster because, you know, you see the question, you say, oh, I can apply this formula, and then maybe, you know, my ratios will change, or I'll be able to cancel something out, subtract something, and eventually the left side will equal the right side. Thank you for listening. Bye.